it's my setup here. We have the SPSS icon there, but most of you can click on Start, All Program, and IBM bought them a few years ago, right? So it's IBM's product. So it's actually, if you go down to IBM SPSS Statistics, right, you can find that. And it is the second one. The first one is for licensing, updating license and whatever. You want to use this one, right? So click on that. You open the SPSS software. Okay, so when you open SPSS, this is usually the first thing you see. This is that SPSS program, main program. Right? Do you have it? Can you see that? Do you? Okay, so this is the SPSS main window, right? Just like most of the window application software, you have this menu bar on top. Okay, this is file. You click on it. That's for you to process the data, create a new file, or open an existing files, and so forth. Okay, so if you move to new, there's data, there's syntax, there's output, and so forth. Data is really this data file. Right? When you try to do a data analysis, of course, you need to have a data file, and you will create it from here. Okay. Then there's syntax. Now, like in 80s, when I did the statistical analysis, I was writing program, right? The old program. There's no window environment that you can click and do things so quickly, right? You just have to know how those programming language and write program and then process data and then show the result. And that feature is still there because if you know how to write a program, it make your work, it'd be more flexible for you, right? You can do all kinds of things with it. Window environment, it has set functions in there, right? It's all set there, and you can only use these. But there are other things that you can use within SPSS. So if you know syntax, right, it'll be very helpful. And I will show you how to do that. You don't have to memorize the program, right? There's, for everything that is shown, is put in this window environment, every function, most of the functionality for analysis, you'll be able to use a paste function to actually paste the syntax into a window. You can save it. That's a nice feature. But anyway, that's actually the SPSS program, right? Syntax. And output, anytime you run analysis, SPSS will generate output. If you like to save those output, you can do that. The outputs file usually take a lot of memory. Well, nowadays, memory is cheap, right? But a lot of time when I do the analysis, I don't bother to save the output. I save the syntax. Or I save some result and copy and paste in my Word document and take it home, right? Especially if you don't have SPSS at home, that's what I would do. I take the result, copy it into a Word document, so that's some figures or text in my Word document, so I don't have to rely on any other software to open it. So that's one thing that I recommend you to do. If you try to do an assignment, you can take it home, right? After you've done your analysis, copy and paste the result in there and take it home and work on it and finish it. That's a good way to do it, okay? So that's new, open new data, syntax output. You can actually open existing data. All right, so just go through that. And then you have some editing functions, view functions, view whatever you like to view in this window. And there are data processing tools that you can actually transform your data, recode your data using these functionalities here. And then this one is really the place that you will go there and do an analysis. These are functions for you to analyze data or clean data or whatever. Okay. Then there's this graphic place you can do. So we're going to go over there pretty soon. So today I'm going to use a data set, show you how to create a data, and then try to do some analysis with it. Right? So where the data is, actually, if you go to our class, let me go to our class website. So if you go to our class webpage, look at the student.htm, right? You don't have to show, I show it to you, right? This is the data. I explain this, how to analyze this data, using doing histogram and whatnot in our class. Right? Remember we talked about height data, okay, weight data, and gender. We did a bar chart for that. Okay, so we have quantitative data. We have kind of qualitative data there. Okay, and how do we create a data file first from using a data set like this, right? And SPS, of course, like most of the software, you can import existing data. So if you have a data created using Excel or using some other database or statistical software, most of them you can import that into SPSS. Okay, but here, the example I want to show is how to create this data. So I'm going to have this maybe you see the data on one side, okay? So I'm going to start, maybe make up the ID. Question?
Yeah, where do you get that data from?
Okay, let me go back again. This is from our course website. Remember our course website? From my webpage, stat 3743, and here there's a student.htm. Okay? That's the data. Okay? So that's how we can get this. Okay, good. Anytime you have any questions, just stop me, right? So let's say I want to create first variable, it's ID, so I click on this first cell. Now this is a data editor. It's not Excel worksheet. So you cannot actually select a range and put in functions in there. It's not working like that. It doesn't work like that, okay? But it allows you to create a data sheet. So I have ID 1, 2, 3, so I can go ahead just enter 1, 2, 3, 4, and keep going. All right? So that's how you put in data into your data sheet. It's easy, okay? And anytime you start putting data in there, it'll automatically create some default variable name for it. Start from VAR0001, and then you have VAR0002, and so forth, okay? Also, you'll see this 2 decimal place. That's a default format. You can change it. Okay, how do you change it? If you look at this SPSS data editor window, at the bottom you see data view and variable view. Okay, data view is this. There's this page. Click on variable view, you go to another page actually showing you the format of each of those variables. Okay. Now, if you look at the data view, this is generally the setup for most of the statistical software for editing data. There you have cells, right, column-wise. Each column is for a variable. And each row is for a case or for a subject, right? For each subject, you observe different variables, right? So first row is for the first subject you observe, and you have like ID, you have like weights and heights and so forth. Make sense? And out of all the software I've seen so far, the arrangement always like that. Column-wise is for variable, and row-wise, each row is the case. You have to keep that in mind because you need to know how to create your data in order to use the software properly to analyze your data, right? Okay, so hope that makes sense. Now, I don't like VAR001. So for the other way to go to the variable view is just double-click on here. Take you to that, also that variable. And I can click here to change that to ID. So instead of variable 0001, VAR00001, I change that to ID. Now this is for naming your variable. And when you name your variable, it should be a character string without any space. Okay? Make sense? You can have letter, you can have numbers, right? But no space and no weird symbol like a palm sign or question mark or, you don't want to, okay? And then numeric, if you click on here, this allows you to change the data type. Your different type of data type, right? Numeric, comma, using a comma, using dots. You want to use scientific notation. You want to use date format. Or string. When you have character string, right? Then you want to use this format, right? But most of the time, even categorical data, I will use numeric type, right? And when I run the analysis, then I will actually use the procedure properly. Sometime in the software, there is an option for you to categorize a numeric value. I will tell you the reason why. Okay, but you can actually just type in character string as a data value too. It's fine. Okay. So anyway, it's numeric, and also width of the value 8, and with the 2 decimal place. So if I want 0 decimal place, so the number will be just whole number showing on the screen. I change that 0 decimal place, and notice this part on the variable view page, there's a decimal too. You can change it there too. Right? So if I click OK, that changes to 0. And of course, you can also click here to change it. Right? So there are several places to do that. Okay. Make sense? All right. So if you go back to data view, now it's all whole number without decimal place, so it looks nicer, it matches closer to your data, original data. Make sense? Okay, that's, if you don't want to enter quantitative data, that's it. That's very simple. Okay. And that's ID. Now go back to variable view again. There are more columns here for formatting your data. There is a label column. Here is a place that you can type anything. Okay, I type student ID and with the space, that's fine. It'll take it. Okay, this is a place for you to actually label that variable. Actually, also give a good description of that variable. So when you come back to a variable, I'm sorry, when you come back to that data sheet, so that data sheet will be more readable, understandable. Okay, it's a nice feature. So if I now go back to the data view, it's your ID, right? But if you move your pointer under that, you see that student ID? Okay? So it made more sense to you what that variable stands for. Maybe you're conducting a survey, and then after that you want to collect those information, put it in a data sheet, right? The survey had questions. You can actually type the whole survey questions for that particular variable, right? You ask people's preference using a question, right? And so you use that, you give a variable a name, maybe question 1 or Q1 without space, right? Using it as a variable name. Then in the label column, just write out all the whole question there, right? So put all the whole question there. Then you move your pointer to there, and on top of the variable name, you will see the whole question showing there. Okay, so that's really nice. Right? Hope I'm making sense. Okay, so that's this is the ID. Then we have other things. We have height. So maybe height. Here we have 6. We have 63, and so we can keep going. Right? Now you know how to do that. Now I can change this variable to height. Okay, and I can make that a student height if you want to, and that's labeling that variable. Okay. And my data doesn't have decimal place, so I'm going to reduce that to 0 decimal place. It's numeric. That's cool, right? So that's good. And then if I click back to data view, I have a height there, right? Variable name changed to a name that makes more sense, and also I had a label there so it shows student height. Okay, so for quantitative data, it's easy, right? Not too hard. Any questions? Everybody follow? Okay. So I guess you can enter weight data now, okay? You can even enter the first ones, they're all numbers. Okay. Now what if, in some cases, you didn't get any value for, like look at this period. When you have information that is not given, so it's blank, right? It's a missing value. So you just skip it. Suppose I don't have the 72 and then I go down to 60. So this piece is missing. You just skip it. And when SBS is on the analysis, it'll skip it, right? So it'll take, if you have 21, suppose it's 21 cases, but that piece of information is gone, so only have 20. So it'll take the average for that 20. So it'll skip that value. Sometimes people actually, the missing value have many different reasons. Sometimes the missing value is just missing. The people didn't respond to that question, so you don't have any information. That's one kind of missing value. There are missing value that is error. Like this one, 6. It's incorrect, right? I knew that it's incorrect. Or maybe I didn't know that, but I ran some data cleaning, I realized that this is a mistake, so I delete it. So if you delete that one, that's a missing value too, but it has a reason for its missing, right? It's an error. So if you want to label these different missing values, you can do it this way, right? This is what people do. Maybe I say A. I know that I won't have a data value as A. I'm going to use A to represent missing value due to error. Okay? And when we have this kind of missing value, I say 9999. I'm going to use 9999 for labeling another type of missing value. That speech is just missing, right? No information available. And you can do that. Okay? But when you do that, you're going to come back to the variable. This is for high variable. Come to the variable view page and come here for missing. This is for high variable, right? Remember, for high variable, if you click on this button here, actually there is another variable on top, right? Click on this button here. It allows you to declare what kind of missing value, what are the missing values. So I actually set up 2 missing values, right? A. It's a discrete. 9999. I only have 3. Well, this allows me to specify 3. You can actually click this to specify a range of number, and those numbers will all be considered as a missing value when you run your analysis. So it depends on what you like to do. Right? I picked it specifically A and 9999 as missing value. So if I click OK now, anytime if you're running this variable, analyzing this variable, When they see AAAA or 9999, it'll be considered missing value. It'll skip. Software will skip that. Make sense? Okay. So if I take an average, you're going to take these two numbers. You won't take these because I have declared that they are missing value. However, while you're reading this data sheet, AAAA 9999 may not make sense to you, right? If you didn't create this data, or you created this data, you want other people to look at it. Other people may not know what that means, right? Well, there is a way out. If you click on variable view again, there is a value column. In the value column, if you can click on this button here. You click it and you'll see this, right? Click on this icon or button there. This is a window allow you to label values, right? So I have AAAA, so I click here, AAA. Value is a label. Let me label that. That's actually missing due to error. Remember that's error. Data is wrong. Okay, click that. And we have value 9999. So for the high variable, whenever it's 9999, I'm going to label it as missing, maybe just data not available. Right? And just make it simple. Right? Data that's not available. So 9999 means it's missing because data is not available. Okay, and I click OK. If I go back to my data view, well, it's still AAAA because I didn't activate the labeling function. So there is a button here. This button here allows you to label the value that you set up right in the value column. So click on that. You see missing, or if you make it missing due to error, missing not available, right? So you label different values, right, in your variable. And how did I do that? I click on variable view, and the value column for that variable, I did that. Am I going too fast? Everybody follow? Okay? Now, just in case you just like to use AAA all the time for missing value due to error and 9999 for missing value due to just data is not available. If you want to do that for all these other, you can copy and paste to that cell, right, for that particular variable. So now from now on, ID also missing value is declared that way. AAA is missing 9999 and it's missing, and they are labeling that way, same way. Make sense? Okay, good. So that's easy, right? So that's high. This is quantitative variable. We have qualitative variable. This is the outcome for flipping a coin, head or tail turn up. Okay. You can just go in and type H and F, or you can go in and type 1 or 0. When you have categorical variable, that takes on only two possible outcomes. Usually when I do the analysis, when I use SPSS, so other software may be different, but if I use SPSS, usually I like to code it as 1 or 0. 1 indicates one category, and 0 will be the other category. So if I want to use 1 indicate male and 0 will be female. Right? A variable that takes on only two values, 1 or 0, we call it indicator variable. Right? That's an important term that you like to know, right? Because later on, if you want to do a statistical analysis in the future too, right, you'll see this term, this terminology come out again when you deal with categorical variables. So let's say we want to do the gender. Right? We have 2 females, so I'm going to put 0, 0, and 1. I guess this is easier than typing male and female, right? 0, 1, 0, 1, and so forth. Okay. So I have 2 female there and 1 male there. This, let's say, so I'm going to create this for gender. So I'm going to call this gender. And remember, I copy and paste there. So I can do the same thing. Right? It's still in my buffer, so I do the copy. So labeling the same. And then this label for the variable name, I'm going to say students. Gender, if you want, good. And if you don't want to see decimal place, change it to 0 decimal place. Oh, hold on. I copied the wrong place now. This is not what I'm missing there, right? Oh, yeah, that's right, that's right. Now, let me go back to the data view. You see 0 and 1 still there, right? I like to make the data sheet also readable, so if there's a 0 and 1, I'm going to label that. When there's a 0, I'm going to label it as a female. When it's 1, I'm going to label it as a male, and also I just copy the missing value to the label too, right? So when there's an 888A, there's going to be a missing value for error, and 9999 is missing value for not available, right? I'm going to click here again to add more label because this is categorical variable. I'd like to know what's 0, what is 1 in this data, right? So I'm going to type 0 for value and go down to the next field. I'm going to type 0 is female, right? So I type female and add. Okay. Then in the value, I put in 1, and then next box I type in male and I add. So I add another 2 labels here. Labeling my data, when it's 0, it's labeled as female, and 1 labeled as male. And if I click OK, go back to my data view, now it's male or female. Okay, you can always click this button here to activate and deactivate that labeling. So that when you're doing analysis, you will know male and female, what kind of internal value they have. Okay, make sense? All right. Now, if you have data value that is, you have the outcome from survey, and your survey asking people's opinion, right? You strongly agree, neutral, disagree, strongly disagree, and it's kind of ordinal data, right? You can have 1 as a strongly agree or strongly disagree, and then 2, 3, 4, 5. So you can enter 1, 2, 3, 4, 5, and label 1, 2, 3, 4, 5 as strongly agree, neutral, disagree, strongly disagree. Right? That's one way you create a categorical variable. Start with numeric and label them. Okay. Now over here, although it says male and female, if you type 0 and 1 and just it'll be automatic. Oh, there's no 2, right? This thing happened. Sometimes when you're creating data, it goes too fast, you may have a 2, right? How do you take care of that? You make a bar chart, a pie chart, a frequency table, you will pick this up. You'll be able to pick this up quickly. But anyway, this shouldn't be there, right? There should be maybe 1 or 1, whatever. You want to see, we have actually, in this case, female, male, female, oh, what am I doing? female, male, female. Anyway, you know what I mean, right? So you can continue typing. So that's how you create a data sheet, okay, with all these labeling in there. So that makes your data sheet readable, right? You can move your pointer here, you understand what that variable exactly is, what that means, right? And then also see these labels with different values in your data. Make sense? It's not hard. It's just take practice. Right? So that's how you create a data. Once you have your data created, you want to click File, Save As, okay, and save it at wherever you like to save it. You can save it on your flash drive. I generally recommend you to take this home. Okay. Whenever you create data, put it in your flash drive, or you have internet connection, you can send emails, right? Or you use Dropbox or whatever, you can put it on the cloud, whatever. Save a copy. Anytime you do something, save a copy. And I also recommend, if you're trying to create a large data set and by typing in data, every once in a while you want to save it, just in case there's a power outage or something. So you don't want to. Usually the system has some kind of backup mechanism there, but sometimes it doesn't work quite well. Right? So every once in a while you should save it, right? Save it. So look at, when you do the save option, you see save as type. It says SPS statistic and asterisk and .sav. That means this file has an extension .sav. SP is a data file. This is standard naming format of naming SPS data. Anytime in the future, too, if you saw a data file has .sav, that means an SPSS data file. Okay. It requires SPSS software to open it. If you try to open it on software, it won't, unless the software has a function for importing the data. Most of the software, statistical software, has a function for importing SPSS. The R software, take that too. SAS is a very powerful software called SAS. They also do that. So you can save it anywhere you like to save it. I said save it under the document and maybe the data, save, and that's how you save the data. Okay. And Next time, just go there, File, Open, Data, and open that file. I recommend you to maybe put it in the My Document or put it in the desktop so it's easier for you to find it. Sometimes you have to check, right? When you save, you got to know which folder you're putting in. That's what I want to say. Make sure you know where you put it, so you won't be struggling trying to find out where it is. Okay. So that's how you save it there. That's just it. Right? It's very simple. Any question? Any question? Okay. This is our course website. Now, in our course website, this thing right next to it, that's actually a data file. That's the data file. Contains the data that in this page. So you can download it. This is not good. I think Explorer, you cannot download it through Explorer. See, I get it, let me see. No, you cannot save it. If you click on it, yeah. How many of you are using Explorer right now? How many are using Firefox? For those who use Firefox, you can download it. Explorer, I think they didn't set it up in a way that you can download. So let me go to Firefox. Just copy this web address and open Firefox. And paste. Okay. Go to this page. Now if you click on it, let you save, right? Open or save. Either way, you like to open it or you like to save it someplace. I already saved a copy. If you want to save a copy, click here to save a copy. Right? Save it in somewhere. Like I said, you can. It's in the download folder. Or you can just click on it and just ask it to open it directly. I hope it opens. Okay, so you just open. So if you can open it, you can download it. You can download it on the drive and open. So everybody got this? Got this? Okay. Good. Cool. Now, so this data all properly labeled except for this one is not no decimal place. Can you change that? Let's go and change it. Right? I don't like this 2 decimal place. I don't like the birthday to be 2 decimal. I don't like anything to be 2 decimal place. Right? So I'm going to just change them all. And again, if you like to label them, go ahead and label, right? You can say this is actually student height. And this is a student weight. Birthday, whatever, right? Maybe students pause, weight, or maybe pause, before. And this is a student after. Okay, you can label these, so you can come back to this. The labels should be there. Right? Oh, there you go. Okay. Okay, so you know how to do that labeling. So there is a labeling for variable. Okay, that you do it here. This is for labeling variable, and the value column is for labeling data value. Each of those data values, especially for categorical data. You set up different number for different categories and then you label those numbers. So you will have a data sheet that is more readable. Okay. And pause 1, pause 2, I say it's pause rate after, pause rate before. I told a joke, but before the joke I said I asked you to measure the pause rate, and after that I asked you to measure the pause rate, and there's a difference in pause rate. I want to see my joke excited student or not. I mean, pause rate too high or not. But anyway, so these are quantitative variable and these are categorical variable. You know that, right? And it's important to know what kind of variable you have so that you can use proper method for analyzing. Right? So I'm going to show you some basic functions, right? How to make graphs and come up and also compute basic statistic measures. So start from quantitative variable. ID. You don't need to see the distribution of ID, right? Well, in some cases, probably. It depends on the data. In this case, you don't need to. So I want to see height. So what you do, click on Analyze, descriptive statistics. This is the place that you always go first, anytime you start your data analysis. Even you already know what you want to do, right? But you want to start from here to check the integrity of each of those values in the variables. So I'm going to click descriptive statistics. When you have quantitative variable, you always go to explore. Explore stands for exploratory data analysis. So I click explore. You see there's a window dialog box. And what do you want to explore? I say I want to explore weight and height variable. You can actually check so many of it. All the quantitative variable, if you like to check their distributions and their some property and descriptive measure, you can do that. I'm just going to start with one. Okay. You see display, it has four. That means it will give you some descriptive statistic and also will give you some charts. Okay. So let's just do this, right? If I click OK, then SPS is going to generate a lot of statistics. Start with some basic summaries. This is how many cases you have, how many are missing, and there's no missing there. And go down, you see mean, trim mean, 5% trim mean means it trimmed the tail end 5%, right? Because sometimes the tail area data are outstanding, right? Incorrect. Probably, not always. But I just give you that reference measure. If you trim the tail, 5% of the distribution, you get this. You get median, you get variance, that's S squared, right? You get the standard deviation, again, the sample standard deviation. Because these are all sample, right? You collect data as a sample. Maximum, minimum of data, range of the data, you know what this range, right? Interquartile range, we will explain that later on when we talk about precision measure, right? And then skewness and kurtosis. Skewness telling you what kind of skewness you have. You have a negative number, that means it's distribution skewed to the negative side. Negative skew, that means it's distribution skewed to the left, right? Negative skewed to the left. Positive skewed to the right. So if you've got a positive number, it means your distribution skewed to the right. Right side is the extreme value or longer tail on the right side. Okay. Kurtosis is how sharp is the distribution, right? Skewness is a measure that people use more often. But you can also see it from the graph. Now, if you go down further, you get the scan and lead plot. Okay. This scan and lead plot, because you only have data from 60 and 70s, right? So for 60, it's put two level because there's not many pieces of data there. Okay. And I'm sorry, not many stand there. You only have two, right? So if you only have two classes, all the data just clusters so closely together, it's hard for you to see the pattern, right? So SPS automatically split it to 60 to 65 and maybe 66 to 70 or 69, right? And so forth. Okay. Sometimes people use 60 to 62, 63 to 64, and so forth. Right? Split it to 5 classes. So it depends. And then if you go down, there's a box plot. There's outstanding data there. Okay. I would tell you how we make this graph later on. So you have quantitative data. Box plot is actually a good plot for exploring the data and finding whether there's extreme outliers or not. A lot of time extreme outliers are bad data. In this case, it's bad data. But not always, right? Extreme value is not always outliers. So you have to know that. When you have those distributions that has right skew, right, or left skew, you expect to see some extreme value on the right side. That skew, you expect to see some extreme on the left side. Right? So any kind of distribution is possible when you're doing your data analysis. So whenever you see outlier, you want to double check to see whether it's correct data. If you have nothing to prove that it's incorrect, you don't want to drop it. Okay? However, in some applications, some people just start with dropping outlier and then do the analysis. Some modeling technique. So it really depends, right? It's for the person who analyzing data to decide what they should do. Okay, but you need to know, right? Outlier doesn't mean it's error. Okay, you don't always throw away outlier. You throw away outlier for a reason, for a good reason. Okay, so I didn't do anything when I did this. I just explore and then pick the value and then just click OK. Okay. You can do something more. There are these options. You can click on statistic. You get some outlier printed and percentile printed. And here there is a 95% They say confidence interval for mean 95%. This is something that we will learn later on in the course. When we do statistical estimation, we always use confidence interval, use an interval. Okay. So I mentioned marginal error in the first lecture. Right? When we try to estimate percentage, I say the percent of people in favor of policy 2000 is 25% with a marginal error of 3%. That helped me to understand, wow, my prediction is like, I have a good confidence, actually 95% confident, that actually the proportion is between 22 to 28, right? 3% plus minus, right, from the 25%. Okay. So this actually helps us to specify a confidence level that we can use to figure out marginal error and find out our interval for estimation. So you don't have to use it right now, but eventually you will do that. Okay. And you can adjust the level. If you'd like to do 90%, you can change to 90%. And plot. You can click on plot. Stem and lead, that's by default, they always do that because stem and lead is part of the so-called exploratory data analysis procedure when it was first introduced, right? So it was put as a default. You can ask SPS to do histogram by check on that. You can also ask SPS to do the normality plot with text. You check on that. What is normality plot with text? While statistical analysis techniques are based on the assumption of data from a normally distributed population. Okay. Now, if I have a data and want to use it for the analysis and try to use those procedures, I want to make sure whether the data is likely from bell-shaped distribution. And this is the option you check to help you to feel comfortable for checking that assumption, whether data is likely from a normally distributed population. So I have that check, and I will explain how do you interpret the outcome. So I click continue. And if I click OK, I have more output there. If I click OK, to generate these things, there's a table of tests of normality. This is a statistical test for us to decide whether we can accept normality assumption or not. Like I said, some of the statistical procedures are developed based on normality assumption. Only good for normally distributed population, right? Only good when you apply it for normal distribution. So if your data does not support normal distribution, your data does not support that it's from a normally distributed population, then that procedure cannot be used. So it's important to check whether your data is likely from normally distributed population. Normally distributed means that bell-shaped distribution, right? Is your data likely from that distribution? Well, look at this number here. This SAG is a number, is a very important number in statistics. Okay. By the end of the semester, if you don't know how to interpret that number, you should not pass this course. This SIG stands for significance level. Right? It's actually observed significance level. We also call it p-value. This number is called p-value. P actually stands for probability. It's a probability value. So this number only goes between 0 and 1. You're not going to see a negative number. You're not going to see a number greater than 1. It's a value between 0 and 1. So how do you decide whether data is likely from normal to the population by using this number? Well, there is a rule. If the p-value, well, say your data is not normal, if p-value is less than, usually people use 0.05, right? So if your p-value is less than 0.05, you're going to say data is not likely from normal distributed population. This is the probability value. So it's almost like the likelihood of the data being from normal distribution. So if this probability is so small, that means the data is not likely from normal distribution. Right? So you're going to say you're not going to accept a normality assumption. Makes sense? Right? And oftentimes people use 0.05 when they use decision, right, based on the p-value. And you will see that. In the second half of this course, we're going to do a lot of those p-values. But at this point, we only use this p-value for determining normality. When you have a sample, does this sample support the data? The sample is likely from a bell-shaped distributed population. Okay. So in this case, it's not. It's a high data or weight data. I don't know, likely from bell-shaped pattern, right? But there's a lot of reasons here. First of all, it has a mix of two populations, male and female, right? So it's not one bell shape. That's one possible reason. The other reason Look at the histogram. They are outstanding. There's an error there. Okay? That error actually just screwed up everything. The original probably normal, but because of that error, it's not normal anymore. So what should you do then? You found that, you should go back, find out what that data is. Wow, that's not good, right? Delete it. Just go there and delete that. It becomes a missing audio. Okay? And then do everything again. Explore, right? Descriptive statistics, explore, and run the same analysis again. You click OK. Well, the normality test is good now. It's 0.129. It's above 0.05. Okay? So now data is likely from normal distributed population. Although we know that it's probably not because there's a mix of male and female, right? But the sample size is kind of small. Now, I hope at the end of this semester you will know how sample size affects the conclusion of your analysis. Usually when your sample size is small, you really don't have much information about the population you're studying. Okay? So a lot of tests are designed for detecting conditions or some claims or some statements. The test itself is not powerful enough to help you to make a specific conclusion. So at the end you always say, well, it doesn't reject, for this case, it doesn't reject normality, right? So because the evidence is not strong enough, because you only there's small data. But if with the small data you still reject that statement, that means, well, you really have strong evidence, strong sign or evidence in saying that data is not normal. Like what we have, we only have 22 pieces of data, but we have piece of data is 6. That's really too extreme, right? So we are able to even use that to draw a conclusion that data is not normal. Gradually you will pick that up, right? But at this point, I just want you to know, there's this rule for you to determine normality assumption. The p-value, that probability value less than 0.05, data is not likely from a normal distributed population. Okay? Let's go more now. So look at this histogram. It's kind of really like we have two pigs there, right? This histogram, does it support bell-shaped distribution? It does not. It actually supports that have two bell shapes. But again, because the sample is small. Okay? So the test itself is not powerful enough to say no. I hope that makes sense. And there is a possibility, great possibility, that the distribution of the population is really bell-shaped, but you come up with this just because your sample size is small. Right? When the sample size is small, the sampling variability is large. When you observe these patterns, right, a lot of times you won't get the really bell-shaped pattern. I have 5 pieces of data, how can I be able to determine actually what the distribution shape of the population? It's hard, right? You're going to get a few pieces of data scattered around, you have no clue. Usually it reaches 100 or 200, and gradually the graph is more likely to reflect what's going on in the population. Let's go down further. Same in V plot. This is called QQ plot. Q stands for quantile. Quantile is like percentile. This chart actually helps us to visualize whether the data follow a normal distribution or not. What it does, it plot the quantile of data versus quantile of normal distribution. Right? Look, this is the percentile. This is 10% of the data versus 10th percentile of normal distribution. 20th percentile of data, 20% of the normal distribution. Keep plotting that. If they follow pretty close, then you should see those that form a straight line pattern. Right? That kind of indicating your data, distribution of the data match pretty closely to a certain distribution. So when you examine QQ plot, quantile plot, normal quantile plot, and you see a dot forming a straight line, those dots forming a straight line, that generally implies that your data follow pretty closely to that particular distribution. Here is the normal distribution. So you see people sometimes, they don't even bother to run the normality test. They just look at the QQ plot. The QQ plot looks pretty good. They accept the normality. That's doing the normality test without actually the normality test itself by graph, quantile plot. Sometimes people call it probability quantile probability. Often used, right? Anyway. And this is, so let's not worry about that. And this is actually a box plot. So removing that outlier, this is the box plot we get. Okay. Cool. So this is when you have quantitative data, this is how you analyze the data, right? Now let me show you that trick for generating SPSS program. You click Analyze, just get the Statistic Explorer. Instead of clicking OK, you click Paste. It actually generated a code that actually did all the work that we just did. Use a high variable, do box plot, scan plot, histogram, normality plot, okay, and do confidence interval 95%. Okay, so if I highlight this, and click this green button means run, okay? Let me go back to my output. So actually I should tell you that when we run this, it generates several things, right? This is output window, okay? First thing you saw was a data editor. Once you have data created, you start doing analysis, then SPS is going to start dumping the output in the output window, right? This is a window that you can save these files too, but usually I don't save them. Okay, like I said, it takes a lot of memory space. And you won't be able to open it at home. If you don't have SPS software, you won't be able to see it. So what I would do, actually, I would just copy and paste these into the Word document, and then go home and write about it. Move these graphs around, and then do my work at home. But anyway, okay. So let me go back here. Let me just delete all these output that I got. Delete everything. So supposedly I should not have anything here. Okay. And I have the data in data editor. So what I want to do is, let's say somebody sent me this data, and they want me to see some result. And I have SPSS here. Right? I don't want to send an output, big, huge output files to email. I just want them to see the result. They know how to run syntax. So I send them the syntax. So on the other end, I receive the syntax. I then highlight everything. I click this. It runs everything. Right? It gives you all the outcomes. Of course, you need to have data and syntax file. Data and syntax file. You have data on your end. Open the syntax file. Highlight all the lines. Run it around, whatever. Down there. So if you're doing a research paper, you submit a paper to a research journal or whatever, and they ask you, well, can you reproduce whatever you've done here? Now, if you have saved a syntax for the analysis, one click, right? Highlight all the text. One click, you generate everything. You can send this to the editor, tell them, well, this is what I did, right? And the result matched what I wrote in my paper. Okay, it's really cool. Of course, you can also use the syntax for data processing. Sometimes data come in not clean and need a lot of labeling and recoding. You can write a syntax for it. So when your data comes, you just write the syntax code for data processing. So syntax is still very useful, right? The syntax, the SPS programming. But if your job is just some simple analysis, people give you data and just do a few click and get it result, then this will be okay, right, without syntax. But to make your SPSS more powerful, it can actually do a lot of different things, right? Okay, good. So let's say I have histogram generated, and I want to write my report, okay? But I don't like the look of this histogram. Now I have these like a green and yellow, don't look like yellow or whatever. I like it to be just black and white, okay? I like this area to be just white, right? So it would be a clean, very clean, nice looking histogram. And less ink to be used, right? And what should I do? Well, anytime you want to edit a chart, just double click somewhere on that chart. You bring out a chart editor that allows you to edit a chart. You can also change the spacing if you want. Okay. Here, I think in the ranges, the class width is anyway. Let's say I want to change the color here. Just click on it. Okay. You see a little green, yellow line around that. That means this area is selected. Okay. You can actually double click there. Let me see. What version is this? Okay. You double click it. You come up to the window. Do you see that? Can you get that? Okay. Now there are different options. Now you can make changes. This fill and border. You see, I'm currently selecting this. Right? It's filled with this color. Click on black and white, and click apply. Then it's black and white. Okay. If you don't like this label here, let me just close it. Right? If you don't like labels, if you don't like the student height, you click on it. You see already a yellow line, circle around it. If you click on it, you go in there. You can change that. Maybe students. Right. You can go in and change, right? The labels on these axes and also the heading of the chart. Okay. So you can do a lot of editing. Once you're happy with it, close it and close it. Go back to the upper window. It'll be a modified chart there. Okay. And if you want to save it, if you're writing the report, you want to save it into a Word document, right? Go to Microsoft Word, open a new document. This is like project 1 maybe, and the title maybe just 6, and maybe name, whatever, album 1. Well, I just made up something. Yeah. Anyway, you were typing a lot of things, and you want a chart to be here. You just come to your chart, upper window, and also, when you write a paper, you don't want a chart cover the whole page. Usually the chart, size of the chart may be definitely less than half a page. Right? So if you copy this directly into it, right, it'll be a graphic, it'll be a picture that's covered, image that be covered, copy. Right? And the font size will be just set for that size of the image. But if you want the picture to be smaller, maintain the same font size, you want to shrink it here first. Make it small. So the font size is still about the same. Okay. Then you do the copy. You do right copy. Go here. Copy. I just did the right. Click. Okay. You still want to shrink, you can still shrink it, just as long as these font size not too big. Usually when you write a paper, people like your font size to be consistent with the font size of your text. Okay. So make your adjustment in the upper window and then copy and paste. If you don't do that, you have a output that is this huge, for instance. You do the copy, and you do the paste. So big and you want to shrink it, the smaller side, then your font size will be small. Okay, you know what I mean? Right? So if you want to maintain certain font size, you adjust that inside the SPSS window. Once you adjust it to a certain size that you feel comfortable with, then you do the copy and paste. You can also copy and paste those tables. But generally, I don't recommend you to, when you write a report, don't recommend you to copy and paste the table directly from SPSS to your writing, to your paper. You should just extract some of the useful information, and then maybe if you want to create a table, create a smaller table yourself, and put it in your paper. Then your paper will look more professionally look. When people are reading, other people try to read your paper, they see the SPSS output, exactly the same format as SPSS, but they will say this is really an unprofessional report. You want to extract useful information that you're going to explain in your paper and put in your table by creating a table yourself. Right? You can actually copy, right-click copy, I think, do the copy. Come here and do the paste. Source format, merge format, text only. There's these different ways to copy, right? If you copy this way, you can actually go in and change the size of the table if you want. But I think you can also copy, I think this version is good, right-click and copy special thing. You can copy it as an image if you want a table to be image. Copy OK, and then copy the table. In itself, it's an image, so you can shrink it. But, you know, this is just for convenience, right? When you write a report, you really won't use this exact report. Like I said, I want you to actually extract useful information, make a table yourself. Okay. Table directly from SPSS, it's only like it's a planning stage of your analysis. You copy and paste into your draft. Okay. Once you try to get your final paper, you don't want to use that format. You want to use your own format. Okay. Hope that makes sense. Any question? Is everything going okay so far? So this is for quantitative data. Okay. Now, if you have qualitative data, we analyze descriptive. Qualitative data, usually you like to see the frequency distribution, right? How many in first class, how many in second categories, and so forth. So just click that, and then just select any of these one at a time, or if you want two, that's fine. Select both of them, and there, okay. If you click on chart, this is the place that you need to be careful. SPSS is an option for histogram. Don't do histogram. You know histogram is for quantitative variable, right? We have qualitative variables. So please check bar chart or pie chart. Don't check histogram. If you check histogram, your chart is going to look weird. It depends on the data, though, right? But chart is going to look weird. You're going to have those bars stick together, right? And assuming it is assuming that the data is quantitative scale, so it's not good. So don't click histogram, right? Bar chart and histogram is different. That's the so bar chart is really just a categorical variable. Histogram for quantitative. So I check bar chart, and I want to show frequency. You can show percentage either way you like. Right? Click continue. You click OK. The display the frequency table, which is something we like to see too. So you see the frequency distribution. You have 9 count tail, 13 count head, 9 count female, 13 count male. You have percentage distribution. You have valid percentage distribution, cumulative percentage. Okay. Why is that valid? Let's go back to the data. If in case I have maybe this is missing. I don't have all the data. Right? Some of the cases missing. Right? Then if you run this analysis, descriptive, frequency, and click OK, you'll find out that report missing value. Okay. So out of those existing value, the value percent is 40 versus 60. Right? If you consider missing value, then the tail is 36, head is 54, and there's 9% missing. Okay. Now in this class, when you report the data, I just like you to report value percentage. Right? You don't have to worry about missing that. Just for this class, right? So that everybody's answer will be consistent. They will just skip missing value. In some analysis, people probably like you to report missing value. Remember in the class I mentioned non-response bias, right? So if you have a data that is 100 cases but 69 missing, then people would question, right? But if you're doing honest analysis, you got to let people know. For that situation, you will do that. Right? By now class, let's not worry about it at this point. Just use the valid data to do the analysis. Don't report missing value. Okay. So in our case, in our class, if you report, you're going to report 40, 60%. That's it. Valid percentage. And then, of course, we also give you the bar chart. Okay, if you don't like that, I have lowercase for C, I can change it to uppercase. So that's a proper way to label it. So what do? Double click on it. Right? Double click on it. And you don't want this to be yellow or green. You just change that to what is it? Y. You don't like this coin here. Just go there and then close that. You're not getting in. The point is not in the right place. Okay, you can change that. Okay. Then you can also just close it. And you want to change the size within this before you put it in. Now, you have head and tail, H and T. If you don't like H and T, you know what H and T stands for, right? Head or tail. You can go in this chart to change it, or you can go into the data editor. Remember? Actually, sorry, excuse me. I label 1 as head, 0 as tail, but I use H and T instead of head and tail. You can go in there, right? Click on value, cell, right, and change head to head, H to head, T to tail. Good? Everything okay? So this is how you organize categorical data. So this is the thing that you do in the beginning of the analysis. For each single value, you want to go through these analyses. You see every piece of data, all the variables have data in reasonable range. There's no outstanding data. Right? This is called data preparation and data cleaning. It's an important step. You definitely want to do that. And also you can display data using these graphs. Now, what if I have two categorical variables, and I like to see the correlation? We mentioned that in class, right? Generally, if you have two categorical variables, I want to make a contingency table, and I want to do cluster bar chart. How do we do that? It's easy. You can go to Analyze. It's still descriptive. Okay? Go down to Class tab. And have two variables, coin, using as well as gender as column. Right? Usually, if you're studying risk factor or risk analysis, the risk factor usually people put it as a row variable, right? Outcome is column. A lot of people do that. You don't have to do that, right? Just usually people do that. And you can display cost bar chart if you want. If you check on that, it would do that for you. And you just click OK. You have the contingency table, you have the cluster bar chart. Okay, it's did it so quickly for you. By the way, today, do we have something today? Yeah, don't forget to turn that in, right? Okay. So again, you can double click and go in there and change the colors. You can actually fill in patterns, right? Different patterns using black and white. And for these, actually, if you go Analyze, Descriptive, Cross tab, you can actually click into Cell to ask this software to report the percentage distribution for each row, or percentage distribution for each column in the table, or overall percentage distribution. You do that and click Continue, and when you try to do the table, it'll report those information. And there are some statistics which we will learn later on, right? That we can use for inferential study. And if I click OK now, the table gives you more information. Row-wise, for tail turnout, male and female is 50-50%. Right? So column-wise, for female, tail and head turns out is 50-50%. Second row. So examining correlation between two categorical variables, class of bar chart and contingency table. Right? Descriptively, I can see going through these output. So that's two categorical variable. If you have two quantitative variables, remember what we do. Two variable quantitative, we like to make a scatter plot, right? To see whether there's a trend or not. To make scatter plot, we got to go to graph. If you click on graph, your chart builder actually you provide information, it will automatically build some chart for you, right? But usually in lecture, I just go to legacy dialog file, and it actually points you directly what kind of chart you want to do. Okay, so scatter plot is here. So I click scatter plot, and I want to do a simple scatter plot. Means I only have two variables. I want to examine the correlation between the two. So I just check on that and click define. What is the x variable? Maybe height. What is y variable? I'm sorry. Y variable height and x variable weight. Right. That's all. Just click them in. Just click OK. I see the scatter plot. This is a scatter plot for that data. You can double click it to activate the chart editor. If you want to do any modification. If you want to fit a straight line to see what kind of mathematical model fit this data, you can check this button here. Actually fit the linear straight line pattern. If you want to fit other model, quadratic or cubic, you can do that. Okay. See that? And if there's a piece of data value you suspect that it's outlier, right? It's influential data. You want to see what that data is. There's this button here. You can click on it. Move the pointer to there. To show you which case it is. This is case number 20. You go back to case number 20. Right? See what's happening with that data. Also see which, you may have IDs, right? You see which subject I give you that data. Cool? Now, There's another thing I'd like to show you. What if you would like to know which dot is for male, which dot is from a female? You can use the gender there, put it as a set marker by box. If you set marker by gender, then you will use different type of marker for different gender. If you have that in there and click OK, you see these green one, this is male, this is female. Okay. Now it looks like weird. It seems like the distribution is not. I mean, the pattern is not like this, right? I'm not exactly sure. But this is small data. Small data, oftentimes you have trouble. Okay. If you want to print this from a black and white paper, it's going to be hard to see, right? So what to do, you can come here and check on the maybe color, shape, and change that to different shade. If you want. Wow. Okay. Click OK. So you have cross mark and then circular mark to mark different type of subjects in the chart. So when you try to modify the chart, just go there. Wherever you like to do modification, go there and click. All right, you will see some window pop up and you'll be able to make some modification. Okay. Good. That's it. That's how you do the basic descriptive statistics. Right? Well, I didn't mention that. If you have one qualitative, one quantitative, what do you do? One qualitative, one quantitative. Since it has quantitative variable, you always go analyze descriptive statistics, explore. Anytime you have quantitative variable in your analysis, go there. Okay. And I check student heights. How about the other variable is gender? So this will compare, help us to see whether there's correlation between gender and height, right? It actually make cut and then side-by-side box plot, which we will talk about next time. So I'm going to click OK. What this will do is, actually, because I use gender as a factor, it'll actually report the heights for different level of the factor. Report outcome for descriptive statistics for male, and report descriptive statistics for female separately. It'll do a normality test for male and female separately. Also, right? So since you introduce a factor, it will do analysis for each categories within that factor. Histogram, you'll do one for each factor too. And at the end, actually also normality plot. At the end, they also give you the side-by-side box plot, right? Help you to visualize the difference between the high distribution or the high distribution between two genders. Okay? Cool. This is a nice software. It's pretty nice software. But it costs money. For my website, I have instructions for another software called R, right? And R, inside R, there's a package called R Commander. You can do something similar to this. It's free. Okay, so just in case you like to play with it, feel free to do that. If you have any questions, you can ask me too. If you'd like to learn more different software. I know that a lot of medical standards are using it because it's cheap. It's not just cheap, it's free, right? And it actually has a lot of fancy functions in there. Anyway. So I think that's all I want to show you today as far as the SPSS and creating data. So you will have assignment. You go to our website, course website, practice problem. I'd like you to try this one. Of course, you have to create SPSS data. Okay. Now, I give you that assignment that you need to turn in. There's a data sheet, right? That data sheet is this one. Okay. I have this PDF format and also Word document. You may be able to make use of that to do some kind of copy and paste and then create a data file quicker, right? Instead of typing it in. But whichever you prefer to do, it's fine. Okay. So after you've done that, you want to create this data. Okay. Create it this way. I'm going to assume that you're going to follow this way. Create your data and do the proper labeling. And so your assignment is actually doing this. Report the descriptive statistic. You're going to use SPS to generate a histogram for showing pattern for weight and height, and calculate mean and standard deviation for weight variable, do bar chart for each variable, and so we'll just follow the instruction. So your assignment, first SPS assignment, is doing this. Anytime you have a chart or table, chart, underneath you want to have a figure number, just practicing the proper way, right, of labeling a chart. If you want to report a table, you're going to have a table like this, and table heading always on top. Table number and then short title on top. Figure number and the short title for that figure at the bottom of the chart. That's the format I want you to use when you produce this, writing this report, whatever, for this assignment. Every time, every table you put on your assignment, I want you to write one sentence to describe what you see. So that's what this assignment is about. Follow a previous link to set up the data file, and then answer the question. Make sense? And I will create an assignment Dropbox on Blackboard. So after you've done that, you submit it to Blackboard Dropbox. The first one, that one you want to turn it in. The hard copy you turn it in. Yeah. If you haven't done it yet, you still have today, right? If you don't have it, you can turn it in today, sometime today, to my office. If you don't see me in my office, give it to the secretary, math department secretary. They will put it in my mailbox, just in case you haven't finished it. If you have done it, turn it in before you leave the class. Remember that assignment, you skip number 7, right? Number 7, the box one. You don't have to do box one. You do the rest of it. Oh, I didn't show you how to do time plot here, but here's video. Now, if you go to my class website, right? I have this SPSS instruction page, SPSS reference page. You go in there, there are videos showing you what we're doing today. Actually, I tried to record today's lecture. It may work. I don't know, right? If it works, I send you a link. Whatever we did today, right? If it's recorded. If it's not, you can always click on these links to show the little clips, right, from different things. But when I created this video, it was many years ago. This is version 16. So the user interface looks slightly different, and buttons seems like some of the buttons are not in the same place, but those buttons still exist there. You can go there. And I also recommend to view this one. SPSS 16 or later. This actually tells you what we did today, but it's a text instruction. Right? So everything, most of the thing we did today, it's in this, I think 12 page or whatever document. So if you need a reference, that's another place you can use. Okay? Good. Questions? Any questions? You feel free, if you like to stay here, start your assignment, you can go ahead and do that. Right? So that will be the end of today's lecture. And if you have the first assignment you want to turn in, don't forget to turn that in. Yes? Fine? Just do next Thursday. So you have a whole week to do it. Okay? And many computer labs on campus has SPS. The library, Barlow, Kusama, they all have SPS. You don't have to download it. Number two, on that practice problem list, number 2 is instruction for you to create a data file, right? Then you will use that data file to actually answer the questions that I asked in my assignment. Again, let me explain that again. In the practice problem page, the second create data SPS data file. This is the format I'd like you to use to create your data. Well, it gives you a general idea, right? You have to actually follow exactly what's in the data to create the data. I suggest you the format, right? How you do the label. But what you need to turn in is this one, this thing here. Right. Number 3, what describe? Yeah, you want to answer these 6 questions using SPSS. And you put your answer in a Word document. And I will create an assignment Dropbox and Blackboard, so you can just submit your assignment. If you like to submit also your data file, you can submit 2 or 3 files together in one submission. So feel free to do so. Okay? Good. Cool. You have 2 things to turn in. 2 things to turn in. One is that activity I asked you to do. The other one is the assignment.